Get started. So to set things up, let's first download the lecture slides and then put it in notebooks from lecture 7 sometime. And then depending on whether you want to use get started. So to set things up, let's first download the lecture slides and then put it in notebooks from lecture 7 sometime. And then depending on whether you want to use the offline or online version of the digital notebook, um, I'm going to quickly show you again. So for the offline version, we're going to use the WordTest. So I haven't installed it yet, but we can do this together. We open WordTest as a web page. And on the right side, under departmental software, we look for Jupyter Notebook for the CX department. It's under the long list of Java for Jupyter Notebook. Only by a single click, then we wait for another 2-3 minutes to finish the installation. Just leave it there. So for the online version of the Jupyter Notebook, we just go to either Google or just to remember the web page as well. So you can Google for Jupyter slide. And click on the web page, select the first object, and Jupyter map. So it will open interactive environment, which is the online version of the Jupyter. And then whichever version you are using, you can download the notebook, lecture 7, the SEYNB, the Jupyter notebook file. For example, I did it here already. You can click on the upload file and look for the file you download. I'll do the same for the lecture 8, but we will only get a start. So this slide. It's okay to open multiple Jupyter notebooks and run them as you wish. Just make sure all the kernels are ready. Once your offline version of the notebook is done, by default, it will pop up a window which asks you which application do you want to open the offline Jupyter notebook. If it's not popping up, you can manually select the copy paste with giving instructions here. Do not close this window, otherwise it will be closed. To access the server, open this file in browser. Alternatively, you can copy paste the URL link to any of the browsers. So it will next to a local host address. For me, it's 4 digits 8. And then you can find where your folders are, including your Jupyter notebook. For me, it's under users. It's in the download folder, so it's under users. My username, download. So there's where I, by default, download the Jupyter notebook from canvas, where it's been downloaded from the source. So I can double click to open that object. Starting from the next lecture, lecture 8, we are going to sometimes require certain packages like NumPy and the plot library. So later we'll illustrate there will be slight differences. Very commonly used packages, it will be pre-installed in the online version, but we may need to manually install it in the offline version. So if you don't bother going through the installation every time, beginning of the lecture, just feel free to use the online version. In many cases, more convenient. So a quick recap of what we did from the last time and what we are going to do today. Last time, we get a very brief introduction about Python, what it's about, why it's popular, why are we learning it. And we start from the data type, the object, and very fundamentally, the assignment. When we assign a value to a newly defined object. Then we spend a lot of time talking about strings. And specifically, how do we access individual indexes? How do we access substrings? How do we use slicing operations? And some corresponding methods. Remember, we have a slightly complicated example that we did not cover, because once we are finished with all the control flow statements, including all the loop statements today, we can go back to revisit that exercise. So we will continue, and we ended somewhere in the middle of the coding statement. So I'll go to the slide and we will take it from there. So for today's exercise, we will try to revisit the frame and the concept whenever possible. And again, I will try to make the analogy compared to Excel, because we learned that extensively in the first class. So for the coding statement, it's relatively simple, yet very, very fundamental. We need to keep in mind that just think of it as any kind of logical expression which can be checked by either true or false. We are kind of already familiar with this because we also use the exact same expression, almost exactly the same expression in Excel. We covered this in the previous lecture. So you can write down any statements, for example, like the relational operators in terms of comparing values or checking whether they are equal or not. Then Python will return you, same as in Excel, will return you true or false. So similar to Excel, the word true and the word false, with the first letter being the uppercase, are dedicated to a Boolean statement. So when they are suggesting that something is true or something is false, it involves bringing false. So this should be relatively straightforward, right? Elementary school math, we're trying to compare the values between two numbers. And we mentioned about this briefly, but the notion of equal in Python is double equal. So pay attention to differentiate this. Other than a single equal sign, which usually means a sign. And the not equal sign is exclamation mark equal. So whenever we are trying to find out whether 2 numerically equals in value with 2.0, it will give us 2. And whether 2 does not equal, exclamation means not equal. 2.0, it will give us 2. So those are the comparisons by value. Well, this may seem very easy, but this is, again, the fundamental of all the future logical statements with these values, which will be more complicated than we are going to talk about. Other than the relational operators using mathematics operations like greater, smaller, greater equal to, smaller equal to, we sometimes also use certain other operators like is or the negation of is or is not. So note that is will be slightly different than the double equal sign in the sense that the double equal sign will only measure the equivalence in value. So 2 will be actually in value equal to 0.0. So this will give us. But if you remember from the object type, 2 is defined as an integer while 2.0 is defined as a float. So the two objects, although equal in value, they are not equal in terms of the object type. So they are not the same. So if we say 2 is 2.0, it will give us 2. It will give us 4 because the object type and are different and they are not the same object. And whenever you see a not, it's the opposite, the negation. The 2 will become false and false. So we'll also try this in a moment. This will be likely different. In most cases, we only care about whether the object is valid or a double equal sign will be enough. But sometimes if you are very picky, you also care about the object value and whether they are the same object. You need to use this. But it's very restricted. And sometimes Python will give you a warning. To suggest, do you mean double equal sign? So we can quickly. And but before, we also have other operators which is more commonly used called in. If you still remember in the previous lecture we talked about strings and substrings. There's a specific method called find, which we'll be using again in today's lecture. So if you want to find a substring within a longer string, it will return you the first index of that substring. But if more generally speaking, you do not care about position of the occurrences of the substring. You only care about the position, whether a substring is contained in the string or not. Then in many cases, you use in or the opposite of not. So the corresponding example, I give you a long sentence, a very famous all work and no play makes it. And then if we want to search or if we want to tell whether a substring, in this case is a little word, work or work with the uppercase W, are contained in the string or not. Note that similar mechanism as I think we are using the find method in the substring. If the cases do not match, like for example, if we look for work, then it will return true. Means that work as a word appears in that. If we look for the word with uppercase letters, it does not make an exact match, so it will give us true. So again, the return value, that is the index, which is what find method will give us, will only give us a Boolean thing, which is either true or false. All the Boolean outcomes are only find. We can only have one of the two possible outcomes. And of course, the not in will just give us the opposite. So join as a name never appears in a sentence. To join in sentence will be false. To join not in sentence will give us. Sometimes it's a little bit special. And of course, we have our old friend. I do not need to spend much time on this because we have extensively covered all of them in Excel. And the usage are exactly the same. For those of you who already kind of forgot about this, we have and, or, and not. Well, not is always straightforward. It just turns into the opposite. And or are exactly the same as we use in Excel. You have multiple Boolean statements, means that each individual statement has the value of true or false. The AND operator will connect multiple of them, usually two. If and only if both are true. In other words, remember, it's being the most restricted. So the only case AND operator will give you true is when both are true. If you have one out of two to be false, or both are false, of course, AND will give you. So the OR statement is the other way around, it's being linear. So as long as you have one of the two Boolean statements are true, it will return. If both are true, then that's the best overall. So the only if and only if both statements are false, then the or statement you can actually find it together in work. Again, let's get ready to run the code in the work. Both of the codes appearing in the workflow are already taking screenshots on the slide. But like I said before, one of the benefits or advantages of running code in the workflow is that you can see the real-time feedback and feel free to change whatever the code is. These are the relational operators when comparing values. So this is a quick example of showing the difference between double equal sign and eight. So here quickly, I'm using the comment to run single line of code at one time. So remember, whenever I use a hashtag, that line of code is being commented out so that it's not equal. So if we check whether 0 double equal sign 0.0 because they are equal in value, Python will tell us this. But if we check whether 0 is the same object as 0.60, it will give us an output, overall output of false because we have different data types. But it will also give us a warning. Sometimes you have a warning message like in a light red color. It does not mean that your code is wrong. It just means that Python finds some ambiguity or some risk of you running it. So the code is still running, but Python is worried that you are not getting what you want. So it's guessing maybe you mean something like here specifically syntax warning. So by warning, it's not an error. So your code is still okay, but you need to double check. If with int literal, if you mean double equal sign, so it's checking with you. Right? So be careful when you use this because this is they're not good. And we can use the statement of or the boolean statement of int in check this already to check whether certain objects like this in this case are the subset. Like what I said, the cases should be fully met. So all of these are very fundamental, but those are the building blocks. All the features, other things. So for those of you who are kind of already forgotten a little bit about the pandas or operators, you can revisit what we covered. So now let's talk about something that we are also somewhat familiar because we learned it as well in Excel, a slightly different. So in Python, we use the if, else syntax to, again, model the different scenarios to break down in different conditions to discuss separate outputs. So here I draw several flowcharts and also use this block of code to show you the thing. So the if syntax, let's take a closer look at the flowchart first. So we are going to specify a boolean statement, in other words, a question or condition that can only be answered by true or false. If your answer is true, then you continue to execute the code below, which is here referred to the so-called code study response. If it's not, means that the condition returns you false, then you skip that part of the code and go to the next executable. Then the next question you ask would be, how do we differentiate which are the codes that belong to the if statement? So in Python, in general, we use different hierarchies or different structures by using different indents. By indents, you are using tabs to have or equivalently for spaces to make certain part of the code a little bit shifted right. So whenever you see a code that it's like you are writing a report and for some line of your paragraph, you have certain indents. But the difference, of course, is that usually you only have indents in the first line of your paragraph. But in Python, whenever you have certain indents at the beginning of a certain line of code, you know that that is the subcomponent of a higher level architecture. Specifically here, the code body 1 belongs to this if statement and code body 2 does not. So that, again, the logic or syntax will be something like we started with the if statement, if, then we write down that boolean statement, followed by a follow. This is the syntax or if. So that I can know, okay, that is the end of our line. Then for whatever code, if the statement is true, we are going to execute whatever the below part of the code that has in. So in other words, we use the indent to differentiate the part of code that belongs to the if statement. And after we run the if statement, this code body 2 is so-called parallel with the if statement. So they are on the same level. So this code body 2 will be executed whatsoever. It does not depend on 2 or 4 of the building system. So that's why we have this overall flow. This is just a flow chart. This does not make indent. Here, the indent only applies to code body 2. So that would be the syntax. Later, we will show in the notebook, you can either use a tab or spaces. And of course, people are more familiar with using a tab because that's simple. To give you a more concrete example, let's use quite relatively old example from Aperture. There was one code that, okay, because if we can't protect the Earth, it can be damn well sure we'll avenge. So that is the if statement. We can think of it in that way, right? So the boolean statement will be whether we can protect the Earth. If we can't, then we'll avenge. But no matter whether we can protect the Earth, the Avengers will assemble anyway. So that was code body one, and code body. So when you write down the code, it will look something like this. And let me repeat specifically, for any part of the code that is followed by the if statement that has the tab or the space or the index next to it, it means that it follows, it's a subcomponent of the if statement, which means that they will only be executed when the overall if statement is true. So let's see what is the condition of the boolean statement. So if not can protect Earth. So whenever you have a not, everything is opposite, right? So can protect Earth is a false statement, boolean statement. Here it's false. So not false is true. So in the end, we will have a true statement that will mean that if we run the code, we will print the base. So it turns out in the end, we will print both. Again, pay attention to the syntax. The if statement should start with the keyword if, and by the end of the line, you should put a colon. Otherwise, we may have error. The colon lets Python know that the condition has been properly ended, and all the code following that will be the valid. And for the tab, again, following on the syntax, you can use a tab key or equivalent to 4 spaces to differentiate or to tell whether which part of the code are belonging to the if. And of course, you can use either a tab, spaces, but not both, because that would be too much of it. And if you have multiple line of code, for example, here for the if statement and printers and print Avengers assemble, they have the same index. Means that if you compare the levels, they are on the same level, so they are parallel. So if does not move as long, they are on the same level. So we will print the Avengers assemble anywhere. The print result does not depend on the realization of the if of the if statement. So this is unconditional. So you can think of this imaginary example. What if we manually change to can protect Earth to true? Then of course Avengers will still assemble, but we no longer print. So that's it. The most fundamental thing of using the if statement. So far it's very straightforward for understanding because it's more or less as what we learned. To make things more complicated, I mean actually Excel, the if function, it's actually more complicated because if you recall, in Excel, in the if function, we actually need to specify 3 things. The conditions, which is a boolean statement, whether true or false. What we do if the condition is true, and what we do if the condition is false. So we have an analogy for that. If you want to differentiate between 2 cases, whether the answer is true or false, if it's true, we do something. If it's false, we do something else. Then in Python, we have the corresponding logical expression called if else statement. So the syntax will be something like this. As same as usual, we start with the if boolean statement. The statement can either be true or false. If it's true, then we run the code body of 1. Means we run whatever code that is in this area. Because here we have an indent, we know that's what the code says. We only run it with the statement. Otherwise, we will have an else. The else is in parallel to the if statement. So it's either one or the other. After else, we do not need to specify anything because the boolean statement is either true or false. If it's true, we run body 1. If it's false, we run the code below else. So code body 2. So the overall flow chart will look something like this. Again, tell by the indent, you can see the structure. Code body 1 and code body 2 are below the corresponding if and else. And code body 3 is on a higher level. So it is in parallel with the if and else statement. So it will be executed in a mechanism. So to use the previous example, we can think of what if the can protect Earth is true, then there's nothing to worry about. We'll just celebrate. So this will be the code body 1, code body 2, and code body 3. So note that this code body 1 and 2, they are mutually exclusive. In other words, for any given boolean statement, can either have true or have false. It cannot be both true. So you will either execute code body 1, which will print you will advance it, or alternatively you will print you will celebrate it. But for code body 3, again, you see the indents are different. It's in parallel with the if else statement. So they are on the same level. So Avengers assemble will always be printed. So when you carefully reason, all the code with clear structures that tell actually by the index to which level, how many different levels are there, and within each level, what's their connection. So this, once you have certain experience, it will be easier for you to tell the different levels. So in this case, we will celebrate it because let's quickly go through. Can protect Earth is true. If not, true will be false. So instead of printing the code body 1, we will print whatever the code body standard is else. So we will celebrate it, and we will print Avengers. Again, quick note on the syntax. We will only execute code body which is the code part under else when the provided boolean condition is a false. Always remember to use the usually by a single or false. It is more complicated. Well, if you still remember back in Excel, the most general case, of course, whenever we have a situation or a scenario in which we have potentially more than some at ECI. So with Excel, we said, okay, unfortunately, we have to use a nested if. In other words, in the worst case, we need to use 15 if nested within each other to be able to answer the question, which types are used. Because for each single if function statement in Excel, we can only differentiate between two things. But well, this is more general. Python is a more general programming language. The Python will allow us to use a slight different thing to deal with multiple scenarios. But of course, in each scenario, we ask a single boolean case, single boolean, we can only answer twice. So this is called, essentially, if you have three outcomes, other than if, else, we will use something like a sequential of boolean cases, which the syntax will be something like else, else. So this middle expression, ELIS, which is the short for else. So the logic actually is similar to what we did with Excel, which provides sequence of tests. So for example, we start with the if boolean statement. So if the answer is true, we execute code body 1 and ignore the remaining. Ignore the remaining means that for the rest of the if statement, they are invalid. We stop it. However, if the answer is not true, so that is the meaning of else. Else means that it's not true. So we have to continue. We continue by asking another test, which is a new boolean statement number 2. So this time, it will again be answered by a true or false statement. If the answer is true this time, it will run the code below else. Otherwise, you may have a third one, a fourth one, continue using else. Every time you can use a single else to differentiate a new syntax. And in the end, for all the remaining cases, you can use the syntax of else. After else, these are all the remaining possibilities, all the left out scenarios. And then, of course, if all the previous ones are not true, you can choose whatever to do with the remaining possibilities. So for all the cases, if, else, no matter how many possible outcomes are there, we know two things for sure. Number one, it should be mutually exclusive, means that body number 1, 2, 3, or even more, at most one of them will be executed. And we know the second thing, all of these possibilities combined together should be everything. There should be no cases left out that we do not consider. Because all the questions can either be answered by yes or no, then in the end, all the remaining possibilities are covered by themselves. So if we draw a flowchart, it will be something like this. And we will use a more concrete example of setting ticket time. So we start by a boolean statement using if statement. If it's true, then we proceed executing the code body 1, and then ignore the rest. Because the remaining of the conditions will be only applied if the first boolean statement is false. Think about the word else and else if, else and else and else here. Else means that whatever appears before was not true. Then we have to use it. If whatever in the beginning boolean statement, in the early boolean statement was true, then we no need to go to that. So this sequence of if, else if, potentially multiple else if statements, and finally else, will enumerate all the potential outcomes, depending on how many of them. Then for each potential outcome, we are flexible to decide what to do within the body of code. You can make different refinements, you can make different limitations as required. Or as required. So to help us better understand, let's use a real world example. I'm not sure whether this is, but it's made up number. I think the real price is to be much higher. So let's decide the price ticket, the ticket price for Disneyland. Let's assume that the Disneyland ticket price is $35 for adults, which is the normal price. However, for customers with different ages, sometimes we have discounts. For example, for senior citizens, which are the people with 60 years old or above, we will only charge for $15. And for children from 3 to 12 years old, the price is only $23. And for babies are less than 3 years old, is free. So how many cases we have in total? We have adults. We only need to count for the different prices. One for the senior people, 2 for the children, 3, and for the babies. So we have 4 different scenarios. There are 4 different age groups. So if we rank the age groups from the lowest to the highest, those are 0 to 3, babies, 3 to 12, children, 12 to 16, which are the normal price for adults. Although I don't think from 12 to 16 are counted as adults, they are charged the normal price anyway. And for the senior people, which are year age of 60. If you draw a diagram or a flow chart, things will get very strange because let's just count from the smallest age group to the largest age, right? So we can use a sequence of T, LT, LT, and L stages to differentiate between the different age groups. Once I show you this flow chart, you should be able to understand how they are different. So we start by the smallest age group and ask whether the age is 3 years old. If this is true, we have the baby, and the price will be here. So for each, so here the code body assembly defining a new variable for price and assign different values. By the way, the whole purpose of using the if, else, else statement is to treat different cases potentially different. Otherwise, if you treat them the same, there's no need. So here the purpose is to chart different prices. So we use if, else statement to help distinguish all the options. And to make things clean, we count age group from the smallest oldest. So if it's not true, this is very important because given that the age is less than 3 is not true, then we discuss. Then whether the age is less or equal to 12. Here, in the else if statement, we no longer need to specify whether the age is between 3 to 12 because it's already false. So we know the age cannot be below. So else if the age is less or equal to 12, if it's true, means that we know the age is between 3 to 12, 5 will be equal to 2. Similarly, if it's not under 12, then we know it's above 12. Then we ask another question. Given that the age is above 12, whether the age is less than 50. If it's true, then we charge the normal price of $35. Otherwise, enumerating all the possibilities, eliminating all the previous possibilities, age is not 3, less than 3. Age is not less than equal to 12. Age is not less than 60. Then, of course, age is above 60, which will give us the last, the elder group, and we will charge the price. So note that at the last else statement, we do not need to specify any Boolean sequence because we are considering all the remaining in this case elder. So once we convert or we translate that flow chart into a code, the code will look something like this. Of course, we need to have an initial age to be fed in to the if, else if. And then, indeed, the code is very well structured. We have 4 components of the if statement: if, else if, and finally else. And below each, we have their corresponding code bodies that will only be executed whenever the corresponding if or else if statement are true. And finally, this is a recap of what we learned last week. Once we have the ticket size as an integer, and we want to print it out together with the string, we need to convert the string object type. So for example, you can change the input ages to any different value. This will give you the final. So let's quickly try running this together. Here, if you will pick another example, first session was on Monday. Let me take the same step to the first. So that's the logic, right? If you think about whenever we have lectures, we have satisfied 2 things. So we will have lectures only when it's not public holiday and of course it's not weekend. And for this lecture, we hope we have only on Thursday. So if you combine multiple statements, for example, today, Thursday, today is public holiday or not? Not. Luckily for our course, we do not have any public holidays in this semester. But for another course I'm teaching on Wednesday, we have National Day. Teaching. So whenever we have a public holiday or whenever it is weekend, hopefully we do not need to have any classes. As long as one of them is true, then we do not have any classes. There is no true. And for our course, for this session, we will have the lecture only if it is on Thursday and it's not public holiday. So we can quickly combining it using the and or statement to check whether the final outcome is Boolean. And of course, the no school is false and have class. Otherwise, we will be not having lecture. So hopefully this is still simple. Like we have already learned it back in Excel. And below are also kind of straightforward. We're basically repeating the other year example. The good thing, again, let me repeat. The good thing when you use the interactive Jupyter notebook is that you can manually change. Let's see. If we can protect, we change manually from false to true. Then you can manually check what the output is. So we will celebrate it. And this was the Disneyland ticket price code. For any of the given age, feel free to change whatever age you want to. example, age of 2, it will return us the ticket price 0. And age of 60 will give us older people. So far, it should be, we do not have any age. And the final example, again, is about the new vendor, which we briefly talk about a simple version, kind of simple version in our spreadsheet model. We all like new models in the field of operations management because that's so classic. So a newsboy ordered 550 newspapers to sell. We have certain ordering costs and we have the selling price. So here, if you think about it, the way that we decide on the demand, it is as if we are using the if. In other words, we are determining the sales quantity, or in other words, how many units of products we can sell. In Excel, we kind of did this in one step already. Okay, if you compare two values, you can sell at most either the demand or the order of production quantity. That was the key or classic trade-off in the news vendor model. In the news vendor, instead of producing it, it's ordered to get the same thing. If you order too many, then you can only sell up to the demand, so that all the remaining inventory that you ordered, you cannot sell them. They can only be recycled. If you order too few, and then the demand is higher than your order quantity, then you can only sell whatever is on your hand, so that all the remaining demand will not be satisfied. So if you think about it in a mathematical expression, we use a simple expression of minimum. In other words, the sold quantity will be equal to the minimum between demand and order. But if you want to understand it from a if statement perspective, we are really separately discussing two different scenarios. Whether the demand is higher than the order or the demand is lower than the order. This is the critical point in any of the news vendor analysis, because the demand will be unknown in the reality. We'll never know the real, we can only make assumptions on the distribution, but we will never know the real demand value. Otherwise, if we know demand first, we know the demand is exactly 550. Then we order exactly that amount, and that's the best decision. We do not make too many. It is because that in reality demand is known. So sometimes we order more, sometimes less, and we can sell only the smaller. So if we want to write in Python using this statement, we need to compare the values between demand and order quantity. And depends on which one is lower, then we assign that value to the sold quantity. Of course, argue, okay, why not we just write down a single line of code, assigning the values of sold by the minimum between demand and order. Of course, you can do that. I'm just showing this example to illustrate that this is also equivalent to using a if else statement. So we will make a Boolean statement comparing the value between demand and order. If demand is smaller, means that we order too many, then we can only sell the demand. So otherwise means that we order too few, then we can only sell the order. And our final process will be, of course, the sales revenue minus order cost. So we can compute in that way. And eventually we can print them out after the conversion. If you still want to use the if statement, but to keep your code very compact, means that you want to save some spaces, you can also write the code in this way. It is equivalent compared to the previous line of code. It's a bit harder to understand, but it's more compact. If you are really advanced, you can try writing in this style. It reads the same. So you will make the assignment of a new variable called sold. The sold will be equal to demand only when you order more. Means that only under this condition when the demand is less than order. Otherwise, in else means otherwise here, then sold will be equal to order. You do not need to know. It's not compulsory to write down in this format. As beginners, actually, you want to write the best in Alphabet, unless you are pretty much familiar with it. But you pretty much should understand, should be able to interpret what does it mean if I compress everything into a single line. So, for example, let's quickly go through this exercise at the brain team. So, it's a multiple choice question. We have the values of x and y, and we are trying to determine the value of 2 using if else. But I compress everything into a single line. So it's a little bit tricky. So to determine the value of z, we will first need to break down the individual components. So let's see. So what is the if statement? It consists of the if statement, the Boolean statement consists of 2 subcomponents connected by a for statement. So let's see the values of each subcomponent one by one. So first, x greater or equal to 3, because x is 2.5, so this part is 4. Okay? And the second part, y less or equal to 3, because y is exactly 3, so this part is 2. But we have a not. So not true will again be false. So false or false will give us overall false. So we do not set z equal to 5, but instead we use the else statement. which will give us the z value 1. Hopefully that logic makes sense. So don't get overwhelmed or intimidated by the compact or long expressions. You only need to decompose them into smaller arguments and evaluate each term one by one, then combine them in the end. So the answer will be 1. It's the assignment. And the step-by-step decomposition. We have 2 individual false statements connected by OR statement, which is again false, and we'll use the else because the overall to make things more complicated, sometimes this is analogous to a nested if in Excel. But in Python, it can get more complex. Because if you only have a single if statement, number 2, this is the code we write. At most, you will have one level of indent. It's either the if, which is to the most left side, or you have a single level of indent, which decides in which subcase what do we do by assigning the people type. But if you have multiple layers of if statements, each potential layer can have potentially multiple outputs. For example, just to give you a brief idea, to determine the ticket price of Disneyland, we first need to decide on the age for different ages. Then we also need to decide for each age group, maybe depending on their occupation, there are certain occupations that will have a further. If that's the case, then you will have another if statement within the existing if statement. So this is similar to the next if statement, but more complicated than in Excel. So after you write down the if within the existing if, you will have another index, as you can imagine, right? We use index to differentiate the different level hierarchy. Instead of 2 different levels, potentially we may have more. So whenever you have more than 2, the block of code, the indent will help us decide which one is the higher level, which one is the lowest one. The more to the right, the lower the level. So the block of code in the end, once you have multiple loops or multiple statements, like netted within each other, it's like you are pushing the block in the middle. And we may see more examples. So far, all the things we have covered, I would personally think they are relevant to what we already covered in Excel. So things should not be that tough. But then what we are going to talk about next are things that we did not cover, or things are not very easily done in Excel. But these arguably are the most important concepts in any of the programming languages. Those are loops. Specifically, we're going to talk about while loops and for loops. What is a loop? What is a loop? If you think about the Big Bang Theory, missing branch diagram, for example, whenever we have a loop, we are reusing part of the code. Take a look at the flowchart. Take a look at it. The difference between the loop and previously the if statement is that the similarity is that we also use a boolean statement, but the difference is that potentially we may go back to the while statement again and repeatedly execute the code of this block. So the syntax of the while statement is somewhat similar to the if statement. You start by the while, the word while, followed by a boolean statement, followed by a colon. Then you use indent, indicate which part of the code is belonging to this while loop. But the only difference also makes this important and useful thing is that potentially it will go back again and again. So this is why we call the loop this green color loop. The code will cycle by step. Specifically, as long as the boolean statement condition is true, we will keep running this code over and over again until the boolean statement becomes false. Then we break or we get out of the loop and execute wherever it remains. So in some cases, if you do not specify the condition correctly, you will be stuck in an infinite loop. You are trapped here without breaking the tree, then your code will run forever. But that's a possibility. That's in general. We will use concrete examples to show you how a loop will work, Python, and why it's important. So a few things to note. So the keyword is while. The indents are same as in the if statement. We need to set up a stopping criteria, specifically the stopping criteria for the loop. Again, to avoid infinite loops and stop the code forever. So we need to make sure that at certain point, this boolean statement, after executing the code or maybe a few rounds, this boolean statement will become. So eventually, we will stop and get out and continue whatever the other. So the stopping criteria is very important. So before executing the code, we need to carefully check. So this is the while loop. Later, we're also going to talk about another type of loop, which is called a for loop. And in the last slide of today's lecture, we are going to summarize the difference between the two loops. Specifically, in which case we're going to use it. Let me give you a spoiler. You are using the while loop whenever you are not sure about how many steps it takes. Because if you think about the logic, the while loop will keep executing the same code of block as long as the boolean statement is. In other words, you may not know, and you may not be sure how many times you need to repeat executing. So this is called indefinite iteration, or unknown number of repetitions. We do not know. Later, we will introduce the for loop where we know for sure how many repetitions. But let's focus on the while loop. And if you still remember, in the previous lecture, we say, okay, there were two exercises that are slightly complicated, and we were not ready to work on them. Now, after covering the while loop, we are ready to revisit one of the exercises. I think in slide is around number 16. The GSK is the final example before the control flow. So, for the slide around number, for me, 16. So let's see what we're trying to do. This is the slightly more complicated example. And there might be multiple ways to do it, but we will use the while loop together with certain operations in string as a recap of the string operations we covered. So we are required to write a program to print the initials of a name given by the user. For example, if the given name is John Fitzgerald Kennedy, JFK for the airport for famous guy in history, the output should be the initial letters. So we will first go through this using the while loop. Then if we have time, we will quickly test we provide how it can do it. So this was the code. While loop. So let's read it line by line, understand how does it work. So first, we will have an input function. This function will ask the user, whenever you run the code, it will ask the user to manually pay in a user-specified, a user-defined input. For example, you can type in your own name later when run the code together. And the name could be a sequence, a string of several words separated by, like the GFK example. Let's use the GFK name as an example. It's 3 words separated by 2 spaces. So what we are trying to do is to extract each word first letter, JF. So to start with, we will define a new empty string. But we will not empty string. We will define a new string, which is the name index of 0. Which hopefully you still remember what the name is. Remember, index 0 is the first element. So we will first take the first letter of the name, which is letter J. Then we enter a while loop. So while true. This is confusing for some of you already, maybe, because if you think about it, while true. What does it mean? While true. While true, it's while to be followed by a boolean statement, which is either true or false. But we say it here, it's always true. So we have a central concern that the while loop will always keep running. But no worries, later we will see. Later we will introduce the notion of rate and continuous. That once certain conditions in the if statement is being satisfied, we will break out of the loop. We will talk about that in a few minutes. So while true means that by default, we will keep running this loop of code. Here, all the block of code will have the same index, means that they are all under the same while loop. So we are going to run the same block of code over and over again, as long as we are not exceeding them. So what exactly we do? We first use the find method to find the index of a space. Recall that previously in the previous lecture when we talked about strings, we talked about this find method. Specifically, it will return us the first appearance of a certain substring. For example, if we want to find a space, it will give us the index of the first appearances of the empty space, which is after join. It will give us this move. Then, depending on the result of the index, so if we run the code, whenever you are running an if statement or a for loop or a while loop, you can, without executing the code, you should be able to think or imagine what would be intermediate output in your head. Try to imagine things. So we first try to find where is our first space. Here we have a breaking condition, means we stop the loop whenever the index is minus. If you still remember, the method find, if it cannot find anything, in other words, if the current name does not have any space, it will give us minus. Let me repeat. The index -1 does not mean that we have the last index. Because we are using a find method, -1 will only be indicating that no result spot. In other words, there's no space in the current name. But to start with, the current name will have a space after drawing. So it will return us an index of 0, 1, 2, 3, 4. It will give us 4. So we have index which has the current value of 4. And the if statement is not satisfied, so we no need to break. We continue to be positive. So then it does assignment of initials equal to initials plus name, index plus 1. So initials, at the beginning, initials are a single letter of J. Now we have a J plus index plus 1, which is the character after the space, which is F. So intuitively speaking, what does the code do? Our true purpose of using the code is to identify all the first letters of each word. But here, the code is actually by finding all the positions of the empty spaces, and identify one character after each empty space. We start the initials by a single letter of J, then we identify the space, we identify F, then we put F together with J, then we get rid of all the previous part of the string before the space. Name equal to name index of 1. Instead, we will get rid of everything before the first. If you are still confused about it, let's run the code together. So let's go to the workbook and scroll up because that exercise was below the kind of quick. It was about the total coding. So here I already give you the name, but of course we can do the same as what we did in the slide by using an input function. Every time we use the input function, within the input function you are writing a comment, so definitely the user put in whatever they type in whatever you want to tell the user. For me, I'll tell myself, please type down your something like that. So we can comment out the CSK example, putting our own name. After we run this code of input function, we will have the comment. We will have print out text. Please type down your name, and there's a separate window for us to type in the manual, like the user specified in the home. Here I will type on my own name, but well, you can type in whatever you want. Like if you want, you can type in ASK. Let me not type in my own name. That will be a little bit painful. Let me also type in the DSK. You can type in whatever word. I think it's maybe a sentence. And our objective would be to extract all the first letters of it. So after this, we can hit enter. So the name, please be checked. The name now will be the string, consists of multiple words separated by. So let's run the code below. Let's run the code below, see what happens. And of course, it will satisfy our requirement by giving us JFK as output. But we never see what happens in the middle. We never see what happens in the middle within the while. So let me give you a useful trick. If you wonder what are the intermediate outputs, print function is very useful. For example, if after we find at each time the index when we apply the find method, we can print the index. So within the loop, this is particularly useful in loops because whenever the loops code are being executed, you will print out the corresponding information. And similarly, here we choose to print out the index, and similarly, we can also choose to print out the corresponding name. And we will see the name will be shorter and shorter. So you can follow me by insert two new line of code. One is print index, the other is print name. You can also print initial. Let me quickly print out everything and see whether it's necessary. Here the names already too short. So let me go back to the original name. Yes, please. So once again, we run the code, and after we put the print functions within the loop, each time the code is executed, it will print out some information, and we need to run the title. So let's break down to what happens within each loop. Let's break down. So we start with a long name consists of 3 different words, and initials at the beginning is a single letter of J, because that's the name of 0, which is the first letter. And within each loop, we first try to find a space. At the beginning, the space is in position number 4, index number 4. So this will give us the number 4. Then we will add the initials by whatever the letter is after that space, which is the letter X. So now our initial will have the letter JX. Right, now we are here. We are printing JX. Now we are updating the name so that the name is only after the index plus 1. So the name is only starting with the letter S. In other words, we throw away join space. So that when we search again empty space in the updated name, we look for the second space. So the first space and whatever is before the first space, including the first space, have been thrown away. So now the name is the second and the third one. And we go, after executing this block of code, we go back to the while loop. And because this while is still true, we will execute block of code again by finding a space. Now, by finding the space with only the remaining word, it will give us number 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is the position of the current index number 10. Then index number 10 plus 1, which is 11, will give us the letter K, and our initial will be JX. Now we are at the second round of the loop, where our initials will be JFK, and our name will be only the remaining left, only one word. and we print the name to be Kennedy. But we are not done yet. We're not done yet because the while is still true. We need to run the loop a third time. Now the index is to find the space again, but now the name is only Kennedy, no space before, no space after. So the find will give us a -1. So we print out the index is -1 as we print it out, you can see here. So now the if statement will be useful because if the index is -1 means that for the remaining name, there's no space. Then we have a break. What does it mean by break? By using the break, we ignore all the remaining part of the code and we skip out of the while loop. Means that all the remaining in the current round of iteration, the remaining codes are not being executed at all. And we just ignore the whole while loop. So eventually we will print out our final initial, which is day. That's what the breakdown detail analysis is part of it. Right. Of course, there might be better ways or other ways to do this. For example, we can manually check, we can manually even copy paste our requirements from the slide and ask, Copilot what will it be. I didn't think you can have anything. I didn't have. I'll be doing the after the session. But let me quickly show you one thing that potentially will ruin this whole lot. Let me summarize this exercise again. The way that we are dealing, that we are finding each first letter of each word is by first finding each space and by identify one position after the space to be the next beginning character of the next beginning letter of the next letter. One quick way to ruin this whole approach is by adding a simple space after the name. So if we do not type our names properly, we end our name by a space followed by nothing. Then if you try running the code, you will have an error. I hope you understand why is this happening. Why is this happening? Because you can imagine after finding the last space, it will give you a 7, which is the current position of the final space. And then we hope that after the space there will be another word. Then we find whatever the letter appears after the space, but the space is the end. There's nothing more. So we have an index out of range. So in other words, there's no letter, no other characters after that final space. So whenever you are referring to index of 1, it's out of range. So this will give you an error. So if you understand how the code works, well, you understand why we have context. So of course, you can try out different things, like using the input function and typing your own name. A sequence of sentence or whatever, then to see what will be the output. Of course, more common to answer the time. I'm just followed my name with a random other. So if we done this correctly, it's giving me HLRN. And hopefully you see what are the detailed procedures of breaking down by identifying the spaces and the corresponding letters after. Let's have around 30 minutes, 30 minutes. I'm back around 35. I try to do this. Do you have any questions from not relate to anything else. So then we are ready to talk about the other type of loop, which is for loop. Personally, I think for loop, after learning both types, for loop is more often used. More often used. Briefly show the difference. So in terms of the syntax, it's almost exactly the same. For followed by, instead of a boolean statement here, it's slightly different. A certain item in a sequence of items. So here the sequence can be a list, can be a string, or can be any, or even later we can see can be a data called data set, array. So in terms of the logic, it's similar. It will enumerate for all the individual items in a sequence. We will see that other example that we did not cover in the previous example. So note that the difference between the for loop and the while loop is that for a while loop, we mentioned that they are called indefinite loops because we will not know for sure how many times we repeat the loop. We will keep repeating the while loop as long as the condition is true, and we will stop when the condition becomes false. But for loop, it's more structured. Before we even execute the for loop, we design and we know how many times the code will be executed because we are enumerating each item and repeat for each item in the sequence. So for example, if you have a sequence of 10 different items, you know the loop will be repeated 10 times. So now hopefully you understand why I'm saying that for loop is slightly more widely used than while loop. Because in more applications, you know, or you want to know how many times you need to repeat the code. Because in this course, we are learning business analytics, we will be dealing with data. For example, one of the most widely used applications for using for loop is to apply for each observation, each row of your data. Because if you know how many rows are there in your data set, you can use a for loop construct instead of a while. So for loop is you can use it in that. Other than that, the remaining are pretty much the same. You will keep repeating as long as you are not enumerating all the items in the sequence. And after you are enumerating all of them, the loop will end and you will continue with others. So we will use the cheerleading example as the other examples did not cover. So specifically speaking, this block of this exercise, this example is again by using the input function, the users will give it a name. For example, later I will give my name. Then for each letter in the name, because the name is string. As a string, it consists of a list or sequence of individual characters or individual letters, including spaces. So what this block of code will do is that let's break it down before we execute it. For each letter in the name, if the letter, so let's see, what is your name? Then we will type in our name, and the name will be different letters, different words composed of different letters, separated by space. If it's a space, then there's no need to print it out. If it is not a space, then we will print out the letter and shout it out. Shout out each letter, and after enumerating all the letters in the name, we will get out of the loop and finally print something out. Okay. So this is the example. For example, if our name is the name, the user input is Jack, it will go through. Again, this is how the for loop works. It will go through each individual element of the sequence. In this case, it's the individual letters, individual characters J, A, and K. For the letter J, we shout it out. For letter A and K, we shout it out. So this is at least we are doing clearly. But of course, sometimes our space consists of multiple words, so there might be spaces in the middle. And as a cheerleader, we're not supposed to shout out for the spaces, so there's no way we can do that. So we can use a if statement, if space. Now here is the first time that we introduce the concept of continuous. Later we will summarize everything, the for loop, while loop, the break, and the continuous. But here, whenever we are using, let's see, this extra thing is adding into the block. We have an if statement for each letter in the name, so we will enumerate in order all the individual characters in the name. For example, Jack's mark. So if the individual letter is not a space, we will ignore the if statement. If it is a space, we will continue. What do we mean by continue? Continue is different than break. So break will ignore the remaining of the iteration and ignore the overall the whole loop. Means that we jump out of the break. Continue will ignore the remaining iteration, but continue with the next iteration. So later we can try if we have a name called Jack Ma, and whenever we encounter a space between Jack and Ma, by continue, we are going to transition from space to the next end. So in other words, by using a continue, we do not execute whatever code flow in the current iteration, but we do not jump out of the whole loop. We continue with the action. We continue with the action to the next element. So also from here, you can see we have different indents indicating different levels. Because the continue is only happens within the if statement. So it will have an extra index. So let's quickly run this cheerleading example with a small loop. it's under the if statement. And we can try to break it down. Actually, this exercise is much simpler, so there's no need to further break it down by printing the information. First, we use the input function, put in some manual name, like manual user specified. For example, here, okay, my name, so I'll just my name. So the code will appear for each individual letter of my name. You can put in your own name. So what the code will do is that for each letter in the name, if it's a space, it will skip the space, not shouting out the space. If it's not a space, then it will shout out the word by printing out the string. Give me a exclamation. So that is what we mean by period. Right? So let's print it out, see what will happen. Well, of course, it's very energetic, printing out all of my individual letters of my name. Of course, there are no spaces. You can see, right? There's no spaces. If there is a space, we skip that iteration by using the continue. So that in the end, we only print out all the strings that substring individual characters that are not spaces. Even if I have a name with other characters, for example, I have numbers, but they are not spaces, it will be part of my name, so it will also be counted. But all the spaces will be ignored because that is our if statement. And hopefully you understand how this continue works. Our code does not stop there. It's not like break. Because if we use a break here, whenever we encounter empty space, we will stop. But by using a continue, we only stop the current iteration, but we continue to the next iteration, so that it will keep all the empty space. So that is roughly the usage of the for loop. And the for loop is more structured because you are enumerating or iterating a sequence of elements. Whether it's a sequence of characters within the string, or a sequence of numbers within the list, sequence of numbers within the array, or a sequence of index. Well, index is the most widely used. If you still remember, in the previous lecture, we talked about this range function. We say the range function combining with the slicing operation, for example, range 6, will give us a list of index of 0, 1, 2, 3, 4, 5. Well, actually, you can combine for loop with the range function. Later, we will see in our future lecture that to give you a spoiler for I in range. Some suffix. So when you combine the usage of for loop together with the range function, you can use index to refer to the exact position. For example, if you have a data set of 6 observations, you can use I as index and to print your data responding information, something like that. We're not going into that yet because we never introduced what a data set will be like in Python. But we will talk about that in 1 or 2. Something like that, not exactly, depending on what your data is. So this will be very useful, combining the for loop together with the range function in referring to the exact position of your data for your data. But we will see that in the future. Then we're almost done. We will use the last exercise to quickly compare between the two things that we did in the loop. We can insert within the loop, whether it's a for loop or a while loop. We briefly talk about them, right? One is called break, the other is called continue. Both will ignore the remaining execution of the current iteration, but the difference is that break will completely ignore the whole loop and jump out of it. Continue will ignore the current iteration only and go to the next iteration. And we should understand how this works by using the following example. We have a simple string A, B, C, D, E, F, G. So we are using a for loop, and we are trying to print a new string. The new string, by definition, starts with empty string. So a new string is empty. And we are enumerating all the letters in the A string. And if the letter is C, we are going to break. After the if statement, we are going to add in the letter to the loop. So you can imagine what will be the output for the two different for loops. Actually, you don't need to imagine. We already show in the result. In the first for loop, it shows AB. In the second for loop, it shows AB, C. So that's the exact difference with break and continue. Because by using a break, here we have a detailed visualization. By using a break, at the beginning, the new string is empty. So it will add in A, add in B, and when we go to C, which is the third time we run the loop, we trigger the if statement because the if statement requires the letter to. So we trigger the break, and the code will stop them. The loop will stop. So when we print it out, we only have A and B. Right? That's the usage of break. However, if we use continue, let's see. For A, for B, we are the same. For C, we continue from there, means that we do not execute the remaining of the iteration. So C will not be added into the new string, but we do not jump out of the loop. We continue with the next iteration, which is B. So we end up with A, B, D, E, F, G. So everything except for. That's it. Hopefully understand and decide when to use either break or continue when you use them. inside of it. So in the end, ABCDFG will be the result. So let's do another quick multi-choice and multiple choice. So again, we have ABCDFG as a string, and we are trying to put certain letters into it. Specifically think about what happens in each iteration. For letters in a string, so we will enumerate in the order of ABCDFG. The only difference between this exercise and the previous example we showed is that we put this assignment line of code for the string. So we assign them first. So for A, we assign it. For B, we assign it. For C, we assign it and break. So the string instead of AB should stop at ABC. So that's the difference between this and ABC. So the solution or the answer should be. You see, this new string assignment previously was after the break, so it was not executed for C. But here it was before the break. You see, after adding C to the new string, the code stopped. So we end up with ABC. The answer. So a quick summary slide on comparing the while loop and the for loop, and hopefully you already have a certain understanding about the differences between the two. The while loop is indefinite. What do we mean by indefinite? Again, we do not know for sure, or we do not have exact control how many times we are going to repeat. And if you want to keep track of how many times you run the loop, you can self-define a constant. For example, I equals 1. Every time you run the loop, I equals to I plus 1, something like that. But for the for loop, you explicitly have a constant because you have a list of elements to enumerate, to iterate. For the string example, the elements could be the individual characters in the string. For the array example we were seeing in lecture 8, you will go through the indices or the individual elements in numerical values in the. And finally, we quickly compare the difference between break and transition. Actually, by the name, it's kind of intuitive. Break will break the loop and not executing the remaining of the loop. Continue will also not execute the remaining of the current iteration, but it will not completely jump out of the loop. It will go directly to the next iteration by skipping the current. So if you have any further questions, you can either try out in the notebook. Alternatively, you can talk to me already. So that's what fundamental, like simple flow statements. We talk about ruling statements, and or, and most importantly, for loop and while loop. Those two are something that we did not talk about. And to quickly show you during the break, I was also trying asking about the peer leading example. Just to give you an idea, whenever you encounter certain code that you want to get certain explanations, you can either directly copy paste the code to compilers or any other language models. Alternatively, you can also take a screenshot. This image recognition was not very good, like 5 years or 10 years ago. But nowadays, it is quite accurate. It is quite accurate. So it is okay to take, instead of copy pasting the code, take a screenshot and directly send it to the large model and asking it to walk you through over the code. It will do the same job of break down the code line by line and try to explain to you what it is. But having said this so many times, you need to pay attention to have some basic understanding on the tracking. Otherwise, because it's possible, depending on the application, that large models will make certain mistakes. Sometimes we cause hallucinations. You will need to know the context on certain data to be able to tell when it's making a mistake. Otherwise, the mistake will be, so you will believe in it and you will have a mistake on it. So the reason we are learning about this is to try to have the capability of tell a mistake when it happens. But again, for those very fundamental exercise examples, probability of having a mistake from the large model. This is the breakdown. And if you are interested, you can either find more in the notebook or combine it together with any of them. Perhaps compile it, but probably be running the weekend. And we can quickly run the final exercise comparing the grades and then. So this is section number 7. And we'll probably use the remaining time to give you a start on the arrays in section 8, but before that, do we have any questions on this? Because those, especially for those concepts, two concepts of loop, one is for loop, the other is while loop, they are very important. They are very important because not only in Python, in any other programming languages, those who are writing them very useful. Because by using loop effectively, you can save a lot of time and effort. You do not have to repeatedly write certain code. Okay, so if there's no questions, let's close this. And we need certain setups for the section number 8. Depending whether online or offline version you're using or the NumPy. So we're going to talk about two different topics in lecture number 8. One is the Python array using the package in NumPy. The other is data visualization, which we already talked about in Excel, but in Python it's more It's slightly different, right? So let's first talk about array. Right? Before we even talk about array, which is a sequence or a two-dimensional, higher dimensional data set, let me first try to explain why we need to talk about array. So the general roadmap when this course was designed was that we first talk about very fundamental concepts in Python, including variables, assignments, object types, strings. We do not use strings very often in real data analytics, but we use the concept of strings to showcase how we do the index referencing, how we do the slicing. Those will be used. And then earlier in today's lecture, we talked about logical expressions, including groups, statements. All of them will be used. So we will take step by step, and eventually we are going to talk about data analytics. But we cannot take a huge amount of steps and jump directly to working with data. That's too fast. So before that, there will be an intermediate step where we talk about arrays, which is similar to a data set. So if you think about a one-dimensional array, it is similar to a one row or a one column. If I think of a one row of data, or wherever. So we will use NumPy to deal with arrays, and then later when we deal with the real data, we will use more packages. But once we understand how we deal with data, many of the methods applications are readily applicable data sets. So eventually, our goal is to deal with the data. So we will start with array. In the simplest case, we will have a one-dimensional array, which is a single row or sequence of numbers. So to give you an example, we have a final exam grade for 6 different students. And here we have 6 different numbers. Actually, you can connect whatever we learn in array back to the for loop. So we can iterate all the numbers by using for loop. So same as before, we learned this indexing already back in the string. If you want to refer to a specific element in an array, remember that we start coming from 0. So if we want to know the grade for the 3rd student, we will be using the index. Also, if you want to know how many students in total are there in the array, you can use the function called let. So a one-dimensional array is still very, very, very simple. We will generalize with two-dimensional array, which is the most common type that we're dealing with. You can think of a two-dimensional array as a table of numbers, as in a spreadsheet mode. As not a model, as in a spreadsheet. So similar to a spreadsheet, we will have rows and we will have columns. But in Python, the way that we deal with the two-dimensional array is more systematic. We will have responding methods and responding reference. So this will be trickier than less user-friendly instead. But we cannot directly select them and click them. We will need to make certain appropriate references. So before we go to the two-dimensional arrays, which will be the main topic for the array, let's quickly set up the NumPy package. So if you open, let's maybe use 10-20 seconds to open the lecture 8 array computer notebook. If you have it downloaded, you can upload it. The first line of code is import NumPy as NP. We will explain what it means. Let's take some time to upload it and open it. But you can see the first line of code in the first cell of the notebook was something like that. Because we are working with the arrays, some of the functions that we will be using are not Python basic functions. Means that it's not the functions and the usages are not readily available whenever we are opening Python or Python. We will have to load or import the library first. Then we can use the library to responding function. So by this line of code, we really mean that in order to use certain functions in this library, or in this package called NumPy, we have to import them. And NumPy is the short name for, I think it's for numbers in Python. But still the number has 5 letters. So every time we refer to a function, we need to say something like NumPy.function. The name is still too long. We can give it a short name. This is the typical usage that everyone is using this for to refer to as a NumPy. And short for number. So with this only 2 words, 2 letters, if you want to use any of the functions like array in NumPy, you just use np.function. But first, we need to make sure that we can import the text. We are in the online environment using the Jupyter Notebook. We can directly run this line of code. Because the convenient thing is that some of the widely used packages like NumPy and I think the plot package as well has been pre-installed on this online environment. However, if you are using the offline environment as what we did here, so this is the offline environment. I was opening from the localhost, the other version, starting from the workspace. Then if I try to import with NumPy, unfortunately we say NumPy is not available, no module anymore. So if that's the case, if you're using the offline version, or in the future, we encounter this case where the package is not installed, so we cannot import them, we should install them. So there are multiple ways to install a package. And the most common, or maybe the simplest way, is to use CI. So you will type something like pip install numpy. For a small package like numpy, usually it could take less than 2 seconds. And after the installation, for some of the packages, you may need to restart the kernel. Instead, you restart the brain. You can go to kernel. For this one, I don't think so, because you can directly import it. It will work. But in general, it's a good practice to restart the kernel after installing any packages. So you can go to kernel and restart kernel. All the current outputs in the notebook will be locked. So it makes sure to save it. After restart, you can import package again, and we are ready to apply any function using function. If you do not install or import it, you can try running the code directly. It will give you an error because NT is not properly defined. This code without importing the package, you cannot use the corresponding function. So these are the difference between the Python basic function and extra function from the package. We mainly use packages, of course, because they are not basic functions. Usually they are more advanced. So this is one good thing about the Python community because there are so many different packages. So if you need any of them, you can use them directly. For example, especially for those people working with machine learning tasks, you do not need to write neural networks on your own. There are existing packages help you directly use. So that's one thing for the offline version. For the online version, though, it's much more convenient because it's already installed package. We can directly load. So after loading the package, we are ready to use any of the functions included, like array. But remember, it's coming from that package. So before the function name, you will have to use the function name empty stock. Let's go back to the slide. For a two-dimensional array, we will have rows and columns, and later we will see. One tricky thing is about the index referencing. We'll refer to a single element like row number 4, column number 3. That's relatively simple, as long as you remember that it's coming from 0. So this 17 will be referred to index of 2 indexes, 3, 2. Means row index 3, column index 2. It means the row and column. So far, it's the same as what we did in the string. Only difference is that we have multiple dimensions. So in general, no matter how many dimensions the array has, you can measure the following things. Right? The shape. If it's one-dimensional, the shape is only represented using a single number. If it's two-dimensional, it's 2 numbers, meaning the number of rows and number of columns. If it's n-dimensional, then n numbers, indicating the length in each dimension. That's what we call the shape. And then how many number of indexes will be equivalent, will be equal to the number of dimensions. Then the icon number will be the multiplication of all the lengths in each dimension. Right? That's occurred. If you have a table of 6 rows and 3 columns, in total you have 18. Right? 18 icons. So in general, NumPy will allow us to build higher dimensional arrays. In practice, we are mainly dealing with 2-dimensional arrays with rows and columns. But imagine you can have a higher dimensions like 3-dimensional arrays. It will be like cubes, rectangles. So whenever you have an extra layer or extra dimension, you can think of, for example, a 3-dimensional array will be multiple 2-dimensional arrays in the same shape that stack together. You have extra dimension. The reference will be the same. The shape will have an extra parameter. Also, the index will have an extra parameter. If you are dealing with a 3-dimensional array, in this example, the shapes will be 3 or 2, means that there are 3 axes, x, y, z. You have 4 items on the height, 3 items on the base, and 2 items on the other side. We're not going into too much details about higher dimensional arrays, although if you're interested, you can actually ask the pilot to generate maybe a 3 or even 4-dimensional array using NumPy and see what it will look like. But in reality, we usually it's not very often that we deal with high dimensions, unless you are working with. So this is NumPy. Make sure that if you want to use any of the functions in that package, you need to import them. And preferably, usually we give them. And for the widely used packages like NumPy and CLT, the short names are usually conventional. NumPy is usually just used. So to manually create an array, no matter how many dimensions that it has, you can use the function np.array. They manually put in all the values in each dimension. For example, if it's a 1-dimensional array, you will use a single bracket, separate all the values by column. If it's a 2-dimensional array, then of course there will be 2 layers of brackets. Then the inner brackets are each row, and the outer brackets, and this one are the columns. And to make it more visually intuitive, we can separate by different rows using columns. This is the manual way of constructing the memory. So to visualize each result of the array, it will look something. So here we have a typo. Here we have a typo. I don't know why. Here it's 17, but here when I print it out, it turns out to be 71. So here we have different rows and different columns. And for each array, no matter what is the dimension, we have several corresponding methods that we use to access the basic information of the array, including the NDIM, stands for n-dimensional. It will give you the dimension. If it's a one-dimensional array, it only have rows. The NDIM, n dimension, will be 1. Similarly, we will have the shape, the size, and the d type. The first three will measure the dimension and how many rows, how many columns, and so on. The last one, d type, will tell you for each individual element in the array what is the object type. For example, here, because all the individual numbers are essentially fractional numbers, numerical values, you will have the d type. So we have a one-dimensional array, which is 1D. The array shape is 6. So this is kind of special. For the array shape, and so let's take it closer one by one. Dimension is 1, so it's one-dimensional. The array shape, because it's only one-dimensional, so you would expect the array shape is just 6. However, this is something special about the array. Even if it's one-dimensional, the shape is still a tuple. Here is a tuple with one item. By a tuple, we mean pair the number. So instead of a single 6, here we have a 6 comma. So you do not need to understand this. Also, I personally do not understand why this is the rule set by the array. It will make more sense if you use a two-dimensional. We will see it later. The number of items is the total number of elements in the array, so 6, and the object type. So for a two-dimensional array, we will have the corresponding method. Measuring the dimension will be a two-dimensional array. Measuring the shape, now we have two-dimensional of the shape. The first number represents how many rows. The second number represents how many columns. So this would be consistent with what we have learned in this stuff, rows and columns. 6 rows, 3 columns. So a total of 6 multiplied by 3, 18 numbers, or 18 items. And the object type is 0 rows. And similarly, let me quickly introduce several other ways. Instead of manually putting all the individual values in a new array, you can create new arrays if they have special values. For example, if you want to create a 3 by 5 two-dimensional array with all the values to be exactly 1, you can use the function called np.1. You do not need to memorize all the methods or functions because whenever you need them, you can look up. Similarly, if you want to create an array with all the values to be all 0, you can use np.0. But here you need to be quite careful. If the shape for both 1s and 0s, if your shape is a single number, it will create a one-dimensional array of that length. If your shape is a tuple, which means a pair or even more numbers, then it means that you're creating a higher dimensional array. 3, 5, it will give you two-dimensional array with 3 rows. Also, let me quickly introduce kind of special function. Special function called A-range. I don't know if we could call it A-range or maybe A-range. The usage of this A-range is very, very similar to the range function we talked about in the previous one. But the difference is that this A-range function is a special function in the package of NP, so we have to use the np.A-range. In comparison, the range function was in basic Python. So without importing the numpy package, you can actually directly use the range function. If you still remember, the range function will take as many as 3 input arguments. It's the slicing operation, right? Starting point, stopping point, etc. We talked about that exclusively in the previous lecture. This A-range function is similar. You need 3 arguments. In many cases, you can ignore some of them if it's default. So you have 3 arguments. They are the starting point, the stopping point, and the set time. But because this A-range function is in the package of NumPy, it's more advanced, so it's kind of slightly more flexible. So in this example, it actually allows, this A-range function actually allows for a fractional set time. So we can try this out quickly. So if we try this here, let's quickly run the code before. Here for a one-dimensional array, we need to define it first. For the one-dimensional and two-dimensional array, we can measure their corresponding dimensions, shape, size, and things like that. And to construct special arrays, we can use 1, 0, whether it's one-dimensional or two-dimensional. And we can try using this function for A-range. If you run the A-range function with starting point of 2, stopping point of 5, step size to be 0.5, you can imagine the output to be 2, 2.5, all the way to 5. 5 is not included. So 2, 2.5, 3, 3.5, 4, 4.5. 5 is the stopping point, but remember, stopping point is not. So this is one example of A-range. We can also try using range, but unfortunately, the range function, because it's basic Python function, it will not allow fractional steps. So if we try the same thing, we get an error. So step size can only be integer in the range time. So in other words, you can only use step size with 1 or 2 integer. So this A-range is more flexible in that. So this will give us 2, 3, and 4. If you want, you can range it out. You can quickly use the for I and range by 1. give us 2, 3, 4. 5 stopping point will not be. So in reality, feel free to use either way. The other difference is that a range function, the output will be in a range object type, as we can see. A range from the NumPy package will generate an array. So if you want to directly work with arrays, you can use A. Then we will talk about something more complicated, which was kind of a struggle. But we have already talked about some preliminaries using strings. So hopefully this is familiar for all of us. For a one-dimensional array, in order to make a reference to a single element, we just call by the individual index. For example, we use index 1 as to be the second element in the one dimension. In a two-dimensional array, you need to make two references, the row index and the column index. For example, in this example, 0, 1 will give us the first row and the second column. To make things more complicated, remember the slicing operations we learned in the previous lecture. All of them still apply. All of them still apply. For example, 2 columns, then nothing means that we're starting from index number 2, end with the last item and the set size of 1. So this will select starting from the number 71 and all the way to the last observation. And this will be more complicated in a two-dimensional array because now we need to make two separate references, and either of them can use a slicing operation. For example, row-wise, we use comma to separate row and column, and row appears first. So this expression actually we see here, it actually means that for the rows, we select from row index number 3, which is the first 4th row, all the way to the last row. And for the columns, we did not specify anything, so we are selecting all the columns. So we end up selecting the highlighted area here. Right. And this one is the most tricky example. The most tricky example. It's fundamentally different than all of the previous examples. Right? If you think about it, all of the previous examples, they only have a single layer of bracket. But here we have 2 layers of bracket. What do we mean? So here, let me explain to you. The outer layer of the bracket is normal, that we all make when we make a reference, we all have it. The inner layer of the bracket actually means that we are using another list, another array to indicate the sequence of the indices. So we only have one-dimensional indices in a two-dimensional array. So we only care about the rows. Columns are not specified here. So by default, we are selecting all the columns. But how exactly we select the rows? We are selecting the rows in that specific order. Row index 0 first, then row index number 2, then row index number 4. In other words, we're only selecting 3 individual rows in that specific order. Row number 1, row number 3, and row number 2. So if you compare the results, again, sorry for the typo, the 17 actually 71, the 71 should actually be 17. But actually, we are swapping the position of the second and the third row. See, the second row is 25, that's 25, 15.5. Now it's between the first. Because here we explicitly state we want to arrange the rows in that specific order of index 0 first, index 2 second, and index 1 third. And nothing else. So all the remaining rows. So this is it. Because we never specify, we only specify a single dimension. By default, it only care about the first dimension without the rows. So all the columns are being by default selected. So this example, we will revisit this example later when we run the code. And of course, same as what we did in the string, we can do the value update by using a new assignment. For example, if we do not like the current value of the third row, 24, 27, we can manually change by making the correct reference, which is row number 3, index number 2, and by a new assignment, replacing the current row by a new one-dimensional array of 25, 28. So the value will be replaced. You can choose to update one value at a time and the whole row. If it's one value at a time, you can directly make the single reference to element and directly update the value. So this is value update. This is also very common. Suppose you have a data set and you want to update certain values. So this is also a type. I didn't realize we have so many types. After updating the value, we should change from the value 71 to 74. But I forgot to change the value to be 74. So let's quickly run the code together. And I will quickly show you, about the most complicated method. So we have defined previously 2 arrays. One is called array 1D, which is one-dimensional. The other is array 2D, which is 2-dimensional. Right. So in this section, we are trying to make reference and potentially using slicing to select a subset of the array for certain columns and rows with 2 dimensions. So one-dimensional is relatively easy. All the corresponding selections will be exactly the same as what we did with string. Because you can think of string as a one-dimensional array of characters. Only difference is the object type. For example, if we want to select the second number, we can use bracket 1. So it will give us 52.5, that number. If we have a two-dimensional array, things will get slightly more complicated because we need to specify both the row number and the column number, the index instead. So 26 will be the first row, second column. So we use index 0. Well, the real challenging and potentially confusing part is that we can combine the slicing operations in each dimension. For example, here, let's try to guess what does it represent. We already covered this in slide. So for one-dimensional array, this is the same as we do in slicing, right? We're starting from index number 2, and we select the remaining. So this will give us, starting from the third observation, which is 71, all the way to the last. For a two-dimensional array, potentially you can do different things in 2 dimensions. For example, here we are selecting rows onward from row number 4, and then selecting all columns. So this is the slice of the two-dimensional array that we will be referring to. So this example is the example I was talking about as the most complicated example. So let's first try to see. Let me first use a separate cell to print out this array 2D and see how exactly does it work. So array 2D, here we have pairs of brackets, and essentially we really mean something like that. Because we completely ignore the second dimension, we did not specify anything in the second dimension, which are columns. So this will by default select all the columns. And what happens to the rows? The rows are in a separate bracket. It's a separate list, giving us the order of indices in that specific order of 0 to 1. So we are going to select the first row, which corresponds to 0, the third row, which corresponds to 2, and the second row, which corresponds to 1. Usually it should be 0, 1, 2, right? The first 3 rows. But here is 0 to 1, so that we will have the first row, the third row, and the second row. Only that 3 rows. So if we directly run it, you can see, right? The first row is the same here. The second row was previously the third row. So to complete, because we completely ignore the second dimension here. We did not write down anything about the second dimension. If you do not want to be this ambiguous, you can write in the full expression, something like that. This will give you the same result because different dimensions are separated by comma. And in the column dimension, we by default we select everything. So you can put a column there. But this can also be omitted, so you will end up with this. This is less, it's harder to understand, but it's easier, it's more compact expression. These two are equivalent. This comma is being used to separate rows and columns, and this column is representing all the columns that we are selecting. If you want to select an individual column, for example, for example, if you want to select the first 3 rows in that order, and also the first column, only the first column, you will select the three values in 0 to 1 order for the first column only, 18, 24, 25. Right? Equivalently, if you want to select, also do something tricky, 0 to 1. So we do the same thing for the rows and for the columns by selecting 0 to 1, 0 to 1. Then you can imagine what will happen. We will shuffle the second and the third row and the second and the third column. Right, after selecting this, end up with this one. Then we select the 0, 2, and 1. So we end up with only the 3 numbers, not the whole thing. This is. Now I'm encountering 4 errors. Let me try to fix it. By a single reference of the column, it should be 3, 4, 26, 27, 16, 25. But if I want to make more references, further reference based on this, potentially we need to use another line of code. Let me try to sort it. But also it's already sorted. If I get a more detailed answer, I will get back to the next. So in the next week, we will start with the element-wise operation and broadcast. I will see you next.